to the power b. Okay? So consequently, this y of t, the absolute value of y of t, must be less than e to the power b. Okay? So we've shown that any bounded input will lead to a bounded output. Okay? So hence, S2 is stable. Okay? Okay, so any questions up to this point? Do we have any questions? Okay, no? All right. Okay, so we have two properties remaining. One is time invariance, and the other is linearity. All right, so these are two very important properties that will stick with us throughout the remainder of the class, okay? All right. So let's start out with time invariance. All right. So what does it mean for a system to be time invariant? All right. So we say that a system is time invariant if a time shift in the input results in an identical time shift in the output. Okay. So this is saying that a system is time invariant if a time shift in the input produces an identical time shift in the output. Okay. So if you put this statement into mathematical terms, this is saying that if you have an input xn that produces an output yn, then if you delay the input by some time, let's say n naught, then the output will be delayed by the same time n naught. So if xn produces the output yn, then if you delay the input by n naught, the corresponding output will also be delayed by n naught. Okay? So this is the same for continuous time as well. So in continuous time, you say that if x of t produces y of t, then x of t minus t naught produces y of t minus t naught. Okay? Now this statement may not be true for any system. But if it is true, then the system is time invariant. Okay? Now, you can sort of visualize this concept using this following example here. Okay. So suppose that you have this chamber, okay, and you insert a signal through an antenna into this chamber. All right, so let's say you insert a electromagnetic wave through an antenna into this closed chamber, okay? And on the other side, you receive the signal using another antenna to produce the output, okay? So, right, suppose that this signal x of t is some pulse inserted at time t, okay? So suppose you insert this pulse at time t, and then inside this chamber, the signal may go through different reflections to arrive at the receiving antenna, okay? So you may have, the signal going through different reflections, okay, or even with line of sight towards the receiving antenna, okay? So even though you insert a short pulse at time t, but because of this different reflection, the signal you observe at the output may be a dispersed version of the input, okay? So you may observe a signal that looks something like this. All right, so maybe it starts from t and looks something like this. Okay. Okay. Now, suppose that this is a well-concealed chamber so that nothing is perturbed inside, okay? So then if you instead input a pulse at some time t plus tau, right, suppose you insert the same signal x of t delayed by tau, okay, right? You insert the signal at time t plus tau instead, and that this chamber is perfectly sealed, right? Nothing changes inside. Then you would expect, what would you expect at the output? So if nothing changes, then you would expect the same signal at the output, except that it occurs tau seconds later, right? Does that sound reasonable? Okay. So I can't draw perfectly, but something like this, okay? Try one more time. Not getting better. Okay. Right, so again, if nothing changes inside this chamber, then by inserting the same pulse tau seconds later, what you expect to observe at the output is the same signal, but delayed tau seconds later, right? Because the input occurred tau seconds later, the output should also occur tau seconds later, right? That's reasonable, right? Okay? Do you have any questions? Okay? So if this is the case, then the system is time invariant. Right? This is time invariant. Okay? Right. So time invariance means that the system does not vary with time, okay? Now, suppose that, instead of, having this sealed chamber with nothing inside, suppose that we have two people inside. Okay? Suppose you have two people walking around inside. Okay. So in that case, these two people, the position of these two people may affect how this signal is, reflected inside. So then when you insert the signal input at a different time, you would expect to observe something that is different, okay, instead of just a time delay, right? So you may instead observe something like this, right? And if that is the case, then you say that the system is time varying. Okay? Okay. All right, so I hope you have a better intuition of what it means for a system to be time invariant. Okay. Now let's look at a couple of examples. Okay. So are you okay with this?